Okay, so today we're talking about systems of equations, and more specifically, the solutions to systems of equations. So systems of equations, what they are they are two or more equations with the same variables. So in the past, we've talked about one equation, and one equation for the answer we'll typically see a set of points, x and y, that are true solutions, and this is represented either by a graph with one line that might look like, not like that, that might look like this, where you have your coordinate plane, and then you would have a line on it, or it might be something like a table, where you have your x and y points, and then you might have 1 and 2, 2, 4, 3, 6, 4, 8. So either way, with one equation, we're typically going to see a set of points that are the answer. And that's not always true. Sometimes we'll have, like a vertical line where we have different x values, but the same the same x value but different y values, or vice versa with a horizontal line. But when we get into systems of equations, we typically have one solution, no solution, or infinite solutions, and we'll get into exactly how each of those scenarios looks. But it can be represented in a graph using two lines that intersect, that are parallel, or are the exact same line, that would overlap. And we're going to focus on how it looks in a graph first, and then we will, in the next grid, we will get into exactly what it looks like in an equation. So to continue along that point, so solutions to a system of equations. So algebraically, when there's one solution, I'm sorry, let's pause, let's go back. So for a graph, the point xy is where the two lines would intersect. So let's see, what do I want to show you? So we'll look at this right side first. So in a graph, one solution has one point xy that makes both equations true, and that is where the two lines intersect. Algebraically, we'll have one point xy still that makes both equations true. So graphically, we'll see an intersection of lines, whereas algebraically, we'll just have an x and a y coordinate, and there won't be a visual element alongside it. So then if we go back to graphically, when we have no solution, we'll have parallel lines with no intersection. So the lines will run alongside each other forever and ever, and they'll never cross. And then algebraically, for no solution, we'll have two equations with the same slope but different y-intercepts. So we'll see if both equations are in point-slope form, they'll be the same all the way up until we get to that constant. At the end, it'll be a different constant. And then infinite solutions graphically will have two identical lines where they have the same slope, same y-intercept. Same algebraically, it'll be the same slope, same y-intercept, same equation across the board. So, how to tell the number of solutions? We have option 1 that we're going to deal with more later, and that is we put both equations in slope-intercept form. We ask ourselves, is the slope the same? If the slope is the same, then we continue on to step 3. If it's not, if the slopes are different, we know we have one solution at that point. If the y-intercept, or if the slope's the same, then we ask ourselves, okay, is the y-intercept the same? If our answer to that question is yes, the slope's the same and the y-intercept's the same, then we have infinitely many solutions. And if the slope is the same but the y-intercept is different, then we have no solution. Now, the second option for going through these is we graph them. And we can graph these on graph paper, or we can use a graphing software, which we'll get into in a later grid square. But so when we graph them, if we have one solution, what our graph is going to look like. So we have our x and y axis, and then we'll have two lines that might look like this. And then this point right here where they cross, that would be our one solution, where we have a coordinate that fits for both for both equations and makes both equations true. Infinite solutions would look something like this. You're going to have two identical lines that it'll only end up showing up as one line, but you have two lines that occupy the same space. So it might look something like this. And I'll try to draw these as close to each other as I can, but I'm not perfect. So we have this blue and yellow line that kind of overlap each other. They're in the same space. That would be what infinite solutions would look like. And then no solutions would, of course, be two parallel lines, so two lines that are never going to cross. And that might look something like this, where you have two lines that are just kind of off in their own world, going on forever and ever, never going to cross each other, never going to cause any problems. So to look at more in-depth, a more in-depth look for one solution. So here on this left-hand side in our graph, we have one solution that intersects right at this black point that I just put in. Now, at this point, you should have already learned how to graph these and how you'll calculate. Let's make sure I get my phrasing correct here. So you will have already learned how to graph these individual functions. Now we're looking at how to graph them and then find the solution. So in these one solution examples, your solution is going to be that point where they intersect. And we'll get into it more in a future video. However, just for a point of reference, we're going to look at one of these. So let's look at this first one, where if I were to put this in slope-intercept form, I would be left with y equals 2/3 x minus 7/3 for this top equation. And then for the bottom equation, I would be left with y equals negative 5/3 x. And we could put the +0 on there if we wanted to. We don't need to, though. And so if we go back and we look at the equations particularly, we put both of them in slope-intercept form. The slope is not the same, so we know there's only going to be one solution. Now, if we continue on to these no solution problems, we see that we have the green and blue lines are parallel. They never intersect each other. So looking at the graphs, we know there's no solution right away. Now, if we wanted to look at these as just equations, on the right-hand side, I'll put these both into slope-intercept form. Our bottom equation is already in slope-intercept form for us, and this top one would look like this, y equals 4x plus 2. So if we were to do our test on this, we would put them both in slope-intercept form like we did. We would highlight, okay, our slope is the same, so let's check our y-intercept. Is our y-intercept the same? Nope, 2 and -1 are different, so we know that we're going to have no solution. Now, as far as infinite solutions, we're going to follow kind of the same steps, but if you look at these pictures, we kind of have this bluish teal line, it's where the green and the blue lines are actually the same thing. And so when we only see one line, but we have two equations present, then we know we have infinitely many solutions because they both lie on that same line. Now what this looks like as an equation, I will solve this first one on the left. So we have y equals 3x plus 2. And then if I solve this first one and put it in slope-intercept form as well, I would end up with y equals 3x plus 2. And so if we go to our steps, we would check, okay, we put them in slope-intercept form. Is the slope the same on these? As a matter of fact, it is. It's 3 for both of them. The slope is 3 on both equations. Then we would say, okay, I need to go to step 3. Is my y-intercept the same? And my y-intercept is this constant at the end, and I have positive 2 for both, so it's the same slope, the same y-intercept, which means we have infinite solutions. Okay, so these are our three types of solutions that we will get when we look at systems of equations. Just a quick review. We have one solution where the lines intersect and our equations have different slopes. We have no solution where our lines do not intersect. They go on forever and ever and they never touch. And we have the same slope, but we have a different y-intercept. So same slope, different y-intercept, no solution. And now for infinite solutions, we have one line really. We only see this one line, but we know there's two equations. So when we check it algebraically, we have the same slope and the same y-intercept, which is our indicator that we have infinitely many solutions. All right. If you have any questions, let us know. Have a great rest of your day.